Hey everyone. In this video, we are going to focus specifically on the seminiferous tubules and their functions in male sperm cell production. Before we talk about this, real quick, if you see germ cells, this is going to refer to the developing cells that will become sperm cells or sex cells. All right, so just keep that in mind. So you can see they extend from the basement membrane to the lumen. Again, the lumen is going to be a hole that they're able to travel through. They're surrounded. They surround developing germ cells and sperm, which is important because this is going to be their main job is to help with the development and creation of the sperm. Promotes tight junctions to make sure that the blood testis barrier remains intact, which is extremely important to make sure that there is nourishment to the tissues, specifically to the testes, but also to the sperm to make sure that they can continue to do their job because you always need blood. Every organ needs blood. But it also ensures that the blood doesn't cross into the germ cells or the sperm cells. So we keep that nice little barrier to keep them separate. It's also important for the immune system. Nourishment, making sure, just like I said 2 seconds ago with the blood, make sure that the sperm cells remain nourished so that they can continue to grow and mature so that they can eventually fertilize another cell. And we're also going to see the production of inhibin, just like we saw with female reproduction. So a lot of these hormones are similar between the two. And their job is to regulate the amount of inhibin to make sure that there is adequate sperm production. Another really important cell here are the interstitial cells or the Leydig cells because they are going to produce androgens. The main androgen found in men is testosterone. So just keep that in mind. Here's an image of the seminiferous tubules. And again, the testosterone is going to be secreted here as well, specifically from these Leydig cells. What tells the interstitial cells or the Leydig cells to do it? That's going to be luteinizing hormone. So luteinizing hormone is back, and in this time, it's going to tell these cells to create more testosterone. This slide you may want to read a little bit. We're going to read it from bottom up, right? So inside the testes, what's going on here, specifically inside one of the seminiferous tubules, right? So again, this tubules are extremely long and coiled, and this is what happens within them. So from the bottom, we have the basement membrane, and we have the spermatogonium, which is the beginning of this meiosis process. So again, meiosis, it's back. So if you have any questions on meiosis, please let me know. But what's going to happen here is the very first step before we begin meiosis are these spermatogonium are going to go through mitosis and duplicate. So we have more of them, right? So imagine you have a piece of, let's say you have a paper that you want more of. So you photocopy it. So the first thing we do is we photocopy it to have more spermatogonium. Once you have your spermatogonium, we can then begin meiosis, which is the process of making the sex cell. So in this case, we go through meiosis 1 first. And at the end of meiosis 1, which is right here, this is the end of meiosis 1, I'm going to recircle it. So here is the spermata. This is the spermatogonium. This is before meiosis 1. It's one cell. After meiosis 1, we have 2 spermatocytes that are different from one each other. So they are different. Once you have these primary spermatocytes, they are going to go through meiosis 2. And at the end of meiosis 2, they're going to split into 4 genetically different 23 chromosomes cells. And then finally, they're going to finish maturing and they will become the sperm cells. or spermatozoa. Right? This is very similar to what we saw in the female reproductive system. There's only one, well, there's a few differences, but one of the main differences you could probably see right now, we have 4 unique sperm cells that are going to mature into 4 unique cells. If you don't remember with females, in females, only 1 survived. The other 3 became polar bodies and died. In males, that's not the case. All 4 will survive. These cells are very small and they don't require as much energy as the egg. And that's why males can make so many of them. Not only that, compared to female reproduction and female oocyte generation, this happens all throughout the male's lifetime. It doesn't begin in in vitro. It doesn't begin inside the mom. It doesn't end or continue when the male hits puberty at 13, and it doesn't end one day when all the eggs are gone. The sperm cell just keeps going. So this process just keeps on continuing, and this is where it happens in the seminiferous tubules. So at this time, if you have any questions on the seminiferous tubules, their anatomy, their functions, or the meiotic division, please let me know.